In this video, we're going to go over skill number 3, factoring, from our review skills pretest. So when it comes to factoring, there's lots of different types of factoring, which is what makes this skill kind of tough. So when we have something that has two terms like the first one, the first thing we always want to check for is a GCF. And so I want to think about what's the biggest number that divides 16 and 32. And the answer is actually 16. Then I want to look at my variables. I have 3 x's here and 2 x's here. So the most I could take from both would be x squared. So my GCF is going to go in front. After that, I'm going to be left with just an x when I divide 16x to the third divided by 16x squared, because you subtract 3 minus 2 to get just x to the first, which would just be x. Then 32 divided by 16 is 2, and my x squared would divide by x squared. So this would be my fully factored form. Now in number 8, I don't have a GCF because I have 1x squared and negative 25, and their only GCF is 1. So this is a different type of factoring, and this is what we call a difference of perfect squares. Let me spell that correctly. So I know this is a difference of perfect squares because each of these numbers, x squared and 25, are both perfect squares. Because x squared is x times x, and 25 is 5 times 5. And so when we have a difference of squares, so in this case like a squared minus b squared, it's always going to factor into a plus b and a minus b. So in this case I'm going to have x plus 5 and x minus 5. Now 9, 10, and 11 are trinomials, and they're each going to be factored a little bit differently. When we have an a value of 1 or nothing in front of our x squared, we're just going to focus on what multiplies to our c value, which in this case is negative 35, and adds to our b value, which in this case is negative 2. So things that multiply to 35. 1 and 35, not 2, not 3, not 4, 5 and 7. And then I think about, okay, what combination of those numbers could get me negative 2 and negative 35? Well, it's going to be a 5 and a negative 7. So x squared is always going to be x times x, and then negative 35 is going to be 5 minus 7. And then when we go to check, I'm going to end up with 5x minus 7x is going to give me negative 2x, which is what I wanted. And so this is going to be my final answer. In 10, we have a leading coefficient, and we always want to check for a GCF first. So in this case, I want to say, okay, does 2 divide 2, does 2 divide 8, and does 2 divide negative 42? And the answer is yes, so we do have a GCF. So I'm going to take out that GCF, and I'm going to be left with x squared plus 4x minus 21 with that 2 in front. Now I can treat this similarly to the last one. I want to think about two numbers that multiply to negative 21 and add to 4. So I'm going to think about factors of 21. So 1 and 21, 2 does not go into 21, 3 and 7, 4 doesn't go into 21, 5 doesn't go into 21, 6 doesn't go into 21. So those are my only factors. So to get negative 21 and a positive 4, I'm going to need a negative 3 and a positive 7. And so once again, I'm going to have this 2 out in front, and I'm still going to have x, just plain x squared, so that's x times x. And then negative 21 is going to be negative 3, positive 7. And then we're just going to check negative 3 times x would be negative 3x. X times 7 would be 7x. And so those would add to 4x. And so this would be my final answer. Now in number 11, if I try to divide out this 2 like I did in number 10, it's not going to divide 11 or 5. So that 2 is not a GCF, but we always want to check for that first. So instead we're going to go straight into our 2 parenthesis factoring. This time I have 2x squared. So just like we said x squared was x times x, 2 is a prime number, so 2x squared is always going to be 2x times x, or x times 2x, either way. So my first spot is going to be 2x times x. Now, if it wasn't a prime number, we would have more options. But since 2 can only be 2 times 1, these are our only options. Now I know my second spot has to be things that multiply to 5. So in this case, I just have 1 and 5. But they have to add to 11. So let's say I put the positive 5 here and a positive 1 here. Let's check this. So 5 times x is 5x. 2 times 1 is 2x. That's going to add to 7x. Oops, that's not what I want. So let's try again. I'm going to switch my 5 and my 1. So let's put the 1 here and the 5 here. 1 times x is 1x. 2 times 5 is 10x, and those would add to 11x, which is what I want. So my final factored form would be 2x plus 1 times x plus 5.